This is the last question in the multi-choice of last year's AP3. Okay. Now I'm going to use this as an opportunity to try and talk about areas beneath curves, and particularly when you've got these negative areas and what they mean and how to understand them. Okay? So let's just understand this question first, and then we'll talk about the related ideas. For the above diagram, it's known that if this is g of x, they give you this this result, 0 to 6 of g minus f with respect to x is 30, and then they tell you all the rest of these information with the intercepts. Okay. Then they want you to work out, well, okay, what happens if I just want the integral of g? That's actually the question. Okay. Let's just have a look at it. What's this thing telling you here? What's this telling you? G minus f. That's this parabola minus the straight line, right? Now, when you subtract one function from another, you don't just get area beneath the curve. You get the area between two curves, if you remember that from when you first were introduced to integration. Okay. Now, people get spun out a little bit because they think, whoa, wait. This is confusing because there's a negative area going on here. Okay, so is it still going to be the area between the curves, or does this thing become negative and then add back, and it's confusing in general? Okay, so the way I'd like you to think about it is just consider if we took the same two graphs and then just ignored the whole negative problem. Okay, if I moved them all up, I mean, suppose this was the same graph but moved it up 5 units. Okay, and suppose this was the same graph but moved it up 5 units. So now this axis is no longer in the way. It's no longer a problem. Okay? Everything here is positive. Now my first question to you is, if I move both of them up 5 units, okay, what's the relationship between this area, between the two curves, and this area between the two curves? If this is just this moved up 5 units, what's the difference between the two areas? There's no difference, right? All I've changed is the location, okay? But it's still actually the same region. Does that make sense? Now, kind of when you look at this, intuitively everyone gets, oh, it's the top function. If I integrate that from 0 to whatever that is, 6, okay? You integrate that and you'll get this whole area, and then you want to subtract this trapezium-looking thing, okay? So you get that it's g of x plus 5 minus f of x plus 5, and you integrate. Okay, but because all I've done is move both of them up by this constant, right, from 0 to 6, if I actually do this computation, g of x plus 5 minus f of x plus 5, all with respect to x, it doesn't take that much to see that the constants just cancel out. Having moved this up or down, whether it's totally above the axis or kind of above the axis or totally below the axis, if you do this, like if I said, well, let's move the whole thing down, that's what I was talking about before. Suppose I moved it down 50 units. So now the whole lot is now, your x-axis is somewhere up here. Okay, everything's negative, but these 50s are going to cancel. It's still exactly the same integral and exactly the same area as it was before, irrespective of location. Okay, because that negative 50 and that negative 50 will cancel, and you end up back here. Okay. So that whole thing, 30. This whole thing, also 30. Okay? Now therefore, if we're trying to work out, well, what's just the top part? What's the part bounded by the parabola? Now that's why this becomes relevant, and it's different to this question now. Okay? Because now I'm thinking about just this, and I'm bounded to the axis now. Okay? I'm not bounded to this curve, wherever it might be. So now this question and this question are different. So how do I work it out? The difference is just that triangle down the bottom there, isn't it? This one here. Okay, so to work out that triangle, all you have to do, you don't have to form an integral for it. You just have to say base times height on 2. You can just consider it all as positive values, and that'll give you an area of 6, right? 6 by 2 on 2. Yeah, fine. So that's going to be up here, the 30 minus 6, which gives you 24, which I think was B. Okay. Now, I then got asked the question, well, suppose, this wasn't multiple choice, and I actually had to do some setting out and that kind of thing. And I was asked to use an integral to find the area of this triangle. I'm not sure why, because it's just a triangle, but suppose, okay? What kind of integral would you form? And actually, this kind of matters. So there's a lot of different fudgy sort of ways to do this. I'm going to show you the correct way, and I'll show you why I think it's more correct than other ways of doing it. You can actually tell me what the equation of f of x is, can't you? Look at it. It's well defined. It's a straight line. Let's do it in mx plus b. What's the gradient? It's a third. So you've got mx plus b, which is negative 2 in this case. So there's my equation. Okay. So I'm going to be forming an integral with that as the integrand. Okay. Now I'm from 0 to 6, right? Because I'm going from left to right. This is a function in terms of x. So my variables ought to be in x as well. So there's the integral. Okay. Now when you give this a go, well, let's just quickly integrate it, shall we? What do you get? What is your actual primitive function? X squared on 6 minus 2x from 0 to 6. Now you give this a go, and you ought to expect you get a negative result, right? I mean, based on what that triangle is, I'm expecting negative 6, okay? Now here's the thing, okay? If you're trying to work out an area and they tell you you've got to use an integral, okay? You kind of have two choices. You can slap an absolute value sign in the whole lot, because you're like, look, I can see it's all below the axis, okay? And so I can just say the area I'm really interested in is this, because it is, right? This, which gives you 6 out the end, okay? Now some people will do that, and in this case I think you're going to be okay. But in a second I'll show you why I think that's actually not such a great idea. Here's the way I'd prefer. Absolute values you have to be super careful about. Okay? Whenever you bring them into play, you have to justify them very carefully. And in that case, I didn't really justify it at all. I just told you to look at the diagram. Okay? I think a much safer way is just to stick with the original integral, get a negative, and then you can say, as the area is below the axis. So that's accounting for the fact that it's negative, right? It is 6 units squared. And I keep that as a separate thing, okay? Please, 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 please do not get to this point, say, uh-oh, needs to be positive. Ta-da, is 6, okay? That's mathematically, that's kind of like putting a gun to your head and pulling the trigger. Because kind of, where did this come from? It came from, oh, I've got the wrong answer, I better fix it, right? It didn't come from any mathematical justification. Okay? Whereas, this demonstrates understanding, right? This is, I know what it means when this is a negative. And it relates to this, right? Having these two separate, having it as an argument and bringing in units here, I think is a much safer way to go. Okay? Now, I said before, it was dangerous to just slap absolute values over the top of everything, okay? Here's why. Let's do this moving thing again. Suppose we take this graph and it's no longer a third x minus 2. Suppose it was a third x minus 1. Here we go. I think that's what it should look like, roughly. That should be 3, shouldn't it? Okay, now, if I repeat the question, and I say, well, tell me the area bounded between this graph and from 0 to 6 and the x-axis, okay? Can you see what the problem is? You cannot simply whack an absolute value sign on there and get a value out and then go home. Just 2, okay? Because, of course, when you evaluate this integral, you will get, look at it, you get 0, won't you? Sorry, there's my absolute value. So the absolute value 0 is 0, whoopee, okay? But that's not true, right? What's gone wrong? We've formed the wrong integral. You formed the wrong integral there. So if you're asked for area, you're going to need to form 2 integrals here, right? You're going to have to split it apart in some way, okay? Now you could do it this way. You could go, okay, I can do it from 0 to 3. I'll get a negative, and then say, well, that must be 3 units squared. I can go from 3 to 6, and I'll get 3, and then I add them up, okay? Alternatively, I could break it into 2 here. I could say the absolute value of 0 to 3 of that plus, I don't need the absolute value here, that, okay? And that will give you the same area, okay? But again, you can see you have to be careful. It's like, well, why did you put the absolute values here and not on this one, right? You need to explain that in some way, which is why I think this is a safer way to go. Okay? This is far more, I know what's going on and I'm articulating it. Okay? In a pinch, you're in a hurry, sure, slap the absolute value signs on. You'll get the right answer at the end. Okay? But I think this is a more articulate way to say it. Does that make sense? Got to be careful with a bubble.
Yeah, so